Chapter 9, Section 2, Sending a TCP request to a server. If it's sending an HTTP request, it's going to go to destination port 80, and then it's going to assign a random source port number right here. It's going to be an SMT. It's going to go to port 25 with a random source number. These are ports that the server, this port server knows to listen for. These protocols always listen to these ports. You can change it if you need to, but 99.99% of the time you don't. Just what it is. Source port, so send them out to this one. You'll get the destination port, and if it sends the reply, it replies to the destination port. So now it becomes a source and destination. There you go. These source ports, these well-known ports, are important to know because that's where they're listening for. If you send it to a different port, it's not going to listen. Not going to get it. It's not like getting priority traffic. It's like saying somebody else's name. You're not going to respond to it, are you? Now, how does this work? Well, it sends a signal saying, all right, is somebody there? Send a reply, yes, I am there. Okay, we've established connection. We will continue talking. Pretty simple. All three-way handshake. How does it end? All right, I'm sending my end signal. All right, I got your end signal. I will send my end signal. I will acknowledge your end signal. There you go. 1, 2, 1, 1. Wait, sorry. 1, 2, 2, 1. Yeah, my bad. So three-way handshake. How do we do this? Control bits. This is the bit right here on the header where it gets changed to say what kind of data is on here. Urgent, acknowledgement, push, signal, fine, reset the connection. Sometimes you have to redo the connection. A little video just demonstrating it. I suggest you watch because it's nice to have somebody else explain it. Lab if you want to do it. The setup and packet tracer here. Another activity where, hey, so I received, acknowledge what? Signal, send signal, I received acknowledgement, send, blah, 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 check. I got both wrong. Wow. I shouldn't really pay attention, did I? And again, another one. Sends, right? Oh, yeah. Send received. There you go. Should read that before I continue on. Now, we talked about multiplexing and segmenting. This is a segment. It doesn't send the data in one letter. It sends it in a bunch of smaller little envelopes. So instead of getting your car, you get your parts of your car. I'm not sure why you didn't email a car to somebody. Say you get something shipped to you. Say it's a bike. Instead of getting the whole bike shipped to you, you get parts of the bike shipped to you. And then it's reassembled when you get there. That's what happens. It reassembles them in the correct order by your PC. Because it might take a different way to get there. C1 took a different path. So they get out of order, and now they're straightened back out again. Again, a little video on that. Another video about what happens if you lose connection, it resends it. Window size. Window size is the maximum amount of data sent before it says, okay, I got everything, or I didn't get everything, send it again. So if you send 100 megabits, it'll send 100 bits, it'll send 100 bits, and then it'll send replies saying, hey, I got this first 100 bits, or no, I missed bit 5 and 6. In this case, it's 10,000 bits. So this is important to know. So it may be multiple segments, but this is the total size of all those segments are going to be before it has to reply back saying, yes, I got everything, or no, I'm missing such and such. That's how you get it. So what happens here is it sends, did not get an idea, sends, I got one. It should actually be segment 4 right here. Oh, you did not get 2 and 3. I will send 2 and 3 again. It's called congestion control. If this happens a lot, it will start sending smaller amounts before it starts asking for a reply, asking for acknowledgement. So, upside of UDP, low overhead. You don't do any of that process. It literally just sends and then forgets. There's none of this back and forth. So it's much faster. Much quicker. That being said, there is no reassembly or reorganization. And in this case, you notice datagram 3 is not here. It got lost somewhere. You don't always get everything. If you're playing a shooter game, you might have noticed this. If you're listening to somebody talk on a live broadcast, you might have noticed this, or on the phone. That's what happens there. Again, it listens to requests on the predefined ports. Listen to them. Does the same thing, making a random source number And if for some reason there needs to be a reply, which UDP will not typically do, except for rare cases, but the protocol, upper layer protocols working might do. That's why it's important to have that. It'll send it back to there. So again, it works pretty much the same way. Just doesn't use much, doesn't reply back very often. So applications that use TCP, your web pages, your email, telnetting. So since we're doing networking, we do telnet with our routers and switches. FTP, again, you do some FTP with your routers and switches sometimes. For applications that use UDP, TFTP, DHCP, certain types of streaming servers, voice over IP, internet over IP, DNS, these are all basic protocols. They're either designed for small environments, or it doesn't matter if they lose a little bit here and there, or they need to have that immediacy. So if you're talking to somebody, it's very annoying to have things cut out on you. If you're watching a movie or watching some video, it's very annoying to have jerkiness. You'd rather lose some rather than going back and forth and having jerkiness. Again, here activities to clarify those stuff. So now we've gone about the whole thing. Really, transport layer is about TCP and UDP and the differences between them. TCP is reliable. It double checks, make sure everything got there. UDP is just send it. It's faster. It's good for gaming. It's good for IP. Voice over IP is good for immediate video, live TV. So if you're watching a game or a football or League of Legends tournament, that's what you would be using. TCP is for data has to get all the way there. So if you're emailing something, or this video you're watching, it's buffering, so it's trying to send all the extra videos, so you have plenty of space. Here's a little packet tracer. This, give it a shot if you want to. As I said, you don't have to do these. Pretty straightforward, but it might help explain it to you. But really, as I said, transport layer has two protocols, and all the differences between them and why I use them are all that really matters. This should cover Chapter 9 for you. Yep. If I missed anything, no, I think I got everything. Good job on Chapter 9. I'll work on the other chapters as quickly as I can.